That's like your cross multiplication, which you were thinking of, okay? What about for the second fraction? We're going to have the c up there, that comes down, but what other two factors are going to be multiplied in the numerator?
b square f.
B squared, because to go from d to b squared df, there's no b squared, and there's no f. Okay. And then finally, guys, for the last one, since we have the f, we copy down our 2e. And what two factors are going to get multiplied in the numerator this time?
b squared d.
B squared d. Nice. Okay. Is that good with everybody, guys? Any questions about that? Okay. All right. Andre, I think you said let's just make it into one mega fraction, and you could have done that. I just wanted to make sure it was perfectly clear going from one step to the next. So that's our next part. We're just going to make this into a huge mega fraction. So this is going to be equal to all that crap, 2a squared df minus cb squared f plus 2eb squared d. All over the common denominator of b squared df. Okay? And guys, that's just literally addition. Okay? All we did right there was we just combined it, we just made it into one big fraction. So this is addition. And I think we're done, right guys? Because what's the last thing we have to do to show that this is rational?
You have to define b squared df as n and the numerator as m. That's
Yeah.
it.
And guys, what's that step called where you can combine everything and just make it
Definition?
into an integer?
Right.
Closure, right
Closure,
guys?
closure.
Right. Guys, remember, addition, multiplication, and subtraction are all closed under integer operations, okay? All of these are integers. So their product is an integer. The difference of two integers is an integer. The sum of two integers is an integer. This is a product. So we can just call this m over n, right guys? Okay. So this is just by closure. There's one other thing, or maybe a couple other things we should define. So what's one other thing we should probably state about this? Yeah, m and n have to be integers. Good job. So m and n have to be integers. M comma n in z. And then, although it doesn't really matter that much, all right, what's one more thing that we know?
N is not equals to
Yeah,
0.
n should be non-zero, because then it wouldn't be rational, right guys? If you divide by 0, then it's just not a real number anymore. It approaches either positive or negative infinity. And we don't want to deal with limits. That's so Calc 1.
So
Right.
wouldn't the n not being 0 already be implied because it says b, d, and f?
Correct, right, because we already defined b, d, and f to be non-zero, so we don't necessarily have to state it again, but I don't know how picky your next teacher is going to be, so I always go for more detailed
But
analysis.
0 is an integer. It's 0
It is, but you can't divide by 0, right?
Yeah.
That's not rational. That approaches either positive or negative
Negative infinity, yeah.
right? So that's why we have to state that at some point. Okay. All right, guys. Guys, isn't it clear that this form right here, 2x squared minus y plus 2z, is equal to m over n, which is rational by the definition of rational? We're done. Okay? So for step 3, we would say that thus 2x squared minus y plus 2z is equal to m over n, which is rational by the definition of rational. Definition of rational. And we're done. So is this marker. So let me ask you guys, any questions about being able to prove one of these types of rational statements by utilizing our rules and all that stuff? Okay, not too difficult, right guys? It's basically just what we did the other day, except now we just have a little bit different algebra stuff. Alright, so why don't you guys go ahead and try to do letter R number 2, which is basically the same problem, it's actually a little bit easier, okay? So I'll give you guys about 6-7 minutes to see if you guys can work that through. We'll go through the answer together and then we'll talk about divisibility. Okay? Sounds like fun, right? Yeah, go ahead. Oh yeah, that would be helpful, wouldn't it? Sorry, Gino. Actually, I will give it to you if I have one. Okay. There you go. one of the packets? Okay. Sure, no problem. And of course, guys, if you need help, let me know so I can help you guys out. Guys, a couple more minutes to finish up. And then we'll go through one possible proof. So what I did was I started the proof by defining the singular variable we need. We just need x. Okay? And I defined that to be rational by definition rational, x is equal to a over b, or whatever two variables you want to, as long as you're not using x again, okay? I said that b was non-zero, and I also said that a and b were integer values, okay? So that'd probably be the way you want to start off. If you do that, I can at least give you 2 points out of 10 for this. Okay. Now, we're substituting back into, what was it, 7 minus x cubed, or?
5x cubed.
Oh, 7 minus 5x cubed, sorry about that. So, by substitution, 7 minus 5x cubed is going to become 7 minus 5 times the quantity of a over b cubed. Okay, so that's not a big deal, right, guys? I bet you everyone was able to expand that, right? You just said that that's going to be 5a cubed over b cubed, okay? And what you might have also wanted to do was maybe do like the 7 over 1 minus 5a cubed over b, okay? And that's just by multiplication. Somebody tell me, guys, what is the least common denominator between those two fractions?
B cubed.
B cubed, right? Because it's the only denominator, right? That's easy, okay? So what we're going to do is we're going to rewrite both of those using the LCD, okay? And I'm just going to go ahead and write it as one big old fraction so we can just skip that step, okay? Could somebody tell me what their numerator looked like when they combined it into one fraction besides m over n? Go ahead, Ron.
7b cubed minus 5a cubed.
Sounds good to me. 7b cubed minus 5a cubed. Okay. Does everybody understand how Ryan did that? Notice that the 1, to get to a common denominator of b cubed, you needed to multiply by b cubed. There was nothing in that denominator. Okay? So it's just like whatever you're missing, multiply the top on. Notice to go from b cubed to b cubed, you didn't need to do anything extra. So the first term stayed this, or the second term stayed the same. Okay? At this point, guys, what's the last algebraic step we need? Closure. We always need closure, right? All right, so it's like a Lifetime movie. We need closure. All right. We can say that that's m over n, c over d, beta over theta, whatever you want to do. We'll just use m over n. Okay, so by closure equals m over n, m comma n are integers. If we just wanted to be explicit about it, we could say n is non-zero. Okay? And clearly, just like the last example, is it not true, guys, that 7 minus 5x cubed equals m over n, which is rational by definition of rational? And we are done. Okay? So step 3, thus, 7 minus 5x cubed equals m divide n, which is rational by the very definition. Definition of rational. Okay. Generally, when an exam, I'll put something like this one. Okay. Because and I'll probably also put one that of the divisibility ones. Okay. The integer stuff, I mean, that's fundamental stuff. So these are probably like a little bit tougher. I don't think they're too difficult for you guys. But generally, what I do on the exams is the way I work the exams is like I probably have like maybe 5 direct proofs and then 2 of the other types of proofs that we're going to do at the end. Okay, so, and then I also have like some short answer stuff. So just kind of getting you guys to think about maybe in like about 3 weeks when we have an exam. Okay, guys, any questions I can answer about proofs with rationals? Okay, they're pretty much all the same. There's not much difference between them. Okay, divisibility is going to be the last topic that we talk about for assignment number 4. Okay, and you guys know what divisibility is. There's a lot of different ways to define divisibility. Okay. If you guys ever see this statement, okay, A divides B, okay, so this animal right here, okay, we're going to be seeing this a lot. That means that A divides B, okay, that means that B, if you divide it by A, it's going to give you an integer, okay. It means that you can write B as A times some sort of variable or integer value. It means that B is a multiple, and it also means that A is a factor of B, okay? Now, of all those that we want to list out, the one that's going to be most useful to us is this first definition right here, okay? When we start doing proofs, that's going to be the one that's going to help us the most, okay? The other ones are nice to know. They're not necessarily going to be essential for us to know, okay? So I always think of 2 different categories of knowledge. I always think nice to know and essential to know. Okay, this guy's essential. The other ones are nice to know. All right. let's just look at two very, very basic examples where I ask you guys to show me that something's divisible. Okay? So, I want to prove or disprove. Okay? So for the first one, we have negative 8 divides 48. Okay? Guys, we know that that's true. Let's take a look at a number of different ways that we could verify that. Okay? So, somebody tell me, guys, why does negative 8 divide 48? There's a number of ways that you guys could explain that. So.
Negative 1/6, multiplied by negative 1/6 or something like that?
No, not quite. That's okay. Good try, Art. But
8 is multiple of 48?
yeah, because if we were to list out the multiples of 48, we could eventually run into negative 8. Okay, that's one of the reasons. Okay, I don't want to do that because I'm lazy. Okay, so I'll think of a different way to do it.
Because 48 divided by negative 8 is an integer.
Yeah, because if we divide those out, that's an integer, which would eventually give what you suggested. Okay, so one way to describe this is that because if you were to divide, we would say 48 divided by negative 8 is equal to negative 6, which is an integer. Okay? So, and that actually satisfies the third condition. Okay? If I wanted to use the first condition, couldn't I also say that 48 is equal to negative 8 times 6? Which is basically the same thing that you just said, James, okay? Except that I just went through and I used the first definition as well, okay? There's a number of ways that you could say it, okay? I think all three of the methods that we suggested are certainly viable, okay? So either way you guys want to do it, okay? So, does that make sense, guys? If it divides and gets an integer, that's going to be divisible. If you can try to find another number another integer that multiplies by what you're dividing into, it's also going to be divisible. Okay?
Except it's 8 negative 8 times 6.
Oh yeah, that would be helpful if I actually knew my times tables, wouldn't it? So that's why I
Especially
don't
as a teacher.
yeah, well that was the irony of it. So that's why I don't teach basic math. All right. Okay, sorry about that.